Okay, so we are discussing the Baumol model, and if you see the screen, you are able to see the screen meeting me.
Yeah.
So we are discussing the Baumol model, and this is the problem that we have on the screen. So there is a firm who has an annual cash requirement of 5 lakh rupees, and the every time it breaks an investment, it incurs a fixed cost of 25, and there is an opportunity cost of holding cash of 6%. So we can straight away find out our optimal cash size, which is by applying the formula square root of 2 TB by R. So 2 into your annualized cash requirement into your fixed transaction cost divided by your opportunity cost. And you will get the optimal cash size to be 20,412 rupees and 41 paise. तो अगर मैं सपोज यही 20,412.41 ही अपना लॉट साइज करता हूँ, विच मीन्स इफ आई फॉलो दी this thing, optimal lot size as per the Baumol model, what is the transaction cost? See, my annualized requirement is 5 lakhs. Every time I'm withdrawing 2412, which means I'm making so many withdrawals. Now, this particular model and the EOQ model, they assume that these are infinitely divisible. So we don't need to round off. So we will multiply this with the per transaction cost, and we will get the total transaction cost to be 612 rupees and 37 paise. Opportunity cost, as I mentioned, the cash balances can fluctuate between 0 and the optimal cash or the target cash size. It's always better to take the average. So we take half of the optimal cash size, which is there with us at any point in time, into the opportunity cost of 6%. So that will also be 612.37. तो आप यहाँ पे क्या ऑब्जर्व करते हो कि if you are following the optimal lot size, the transaction cost and the opportunity cost is exactly equal to the same. So अगर suppose मैं ये वाला ना follow करूँ, suppose I don't follow the optimal cash size as per the Baumol model. Instead, I am using a conservative policy. तो अगर मैं कंजर्वेटिव पॉलिसी फॉलो करता हूँ तो ऑब्वियस ही बात है कि मेरी आई विल बी using a greater lot size because I would want to keep greater cash in hand at any point in time, which means my number of withdrawals will go down, which means the ordering cost should actually go down, but the carrying cost, because of higher lot size, the opportunity cost will also go up. तो अगर मैं वो करता हूँ तो let's say I have 500,000 का requirement, and every time I'm withdrawing 50,000, so I'm making 10 withdrawals in a year. And every time I incur a charge of 25, which means the transaction cost is 250. So the carrying cost will be half the order size, half the target cash balance into the opportunity cost percentage, which is 1500. And therefore, your conservative policy cash management cost will rise up to 1750 rupees. एंड अगर मैं अग्रेसिव वर्किंग कैपिटल पॉलिसी फॉलो करता हूं तो क्या होगा उसमें? हियर यू विल बी हैविंग अ लोअर कैश बैलेंस ऑफ जस्ट 5000. सो the transaction cost obviously will go up because you will have more number of withdrawals. I will have how many withdrawals now? 500,000 by 5,000, which is 100 withdrawals. Or her withdrawal pay I am incurring 25. So that means my transaction cost is 2500. What about my opportunity cost? It is half of my क्या उसको कहते हैं, the target cash balance at any point in time multiplied by opportunity cost, which is 6%. तो यहाँ पे आप देखो कि transaction cost बढ़ गया, but because of a lower cash balance at any point in time, your opportunity cost will come down, right? So आप देखो, अगर हम OCS follow करते हैं, optimal cash size as per the Baumol model, I am having a cost of about 1225. अगर हम कंजर्वेटिव फॉलो करते हैं तो आई एम हैविंग अ हायर कॉस्ट 1750, एंड अगर मैं एग्रेसिव फॉलो करता हूं तो आई एम हैविंग इवन हायर 2650, इजंट इट? सो सबसे कम कॉस्ट आपको कहां दिख रहा है? Baumol model. So if I plot this, if I want to do a sensitivity analysis, तो जैसे सपोज इसको मैं बेस लेता हूं कि ये मेरा 5000 का लॉट साइज है, माई ट्रांजेक्शन कॉस्ट आर 2500, the opportunity costs are 150, so the total cost will be 2650. Now suppose I want to do the analysis here. I create a data table. In the column input I go and link it to my independent input, which is my lot size. तो मेरे को सारे costs मिल जाएंगे यहाँ पे एक बार में. अब ये टेबल ध्यान से देखो, क्या दिख रहा है आपको? पहले आपका टोटल कॉस्ट देखो, जब आप जैसे जैसे आपका लॉट साइज बढ़ रहा है, व्हाट आर यू सीइंग? You are seeing that your total costs are falling. Can you see 1550, 1283, 1225, and ये यहाँ पे वो मिनिमम हो जाता है. This is where it becomes minimum, and उसके बाद अगेन ये वापस बढ़ना शुरू हो जाता है. और ये जो पॉइंट है जहां पे ये मिनिमम है, यहाँ पे लॉट साइज देखो कितना है, 20,412.41, जो कि ऑप्टिमल कैश साइज है बेस्ड ऑन Baumol model. So that's why it is said that Baumol model actually optimizes your cash management costs. Clear? And यहाँ पे भी आप देखोगे दो ऑब्जर्वेशन होती है कि if you are following the optimal cash size as per the Baumol model, your total cost will be optimized, and at that point intersection you will have the opportunity cost and carrying cost will be the same. Because क्या होगा, जैसे जैसे आप कंजर्वेटिव होते जाते हो, आप ज्यादा लॉट्स ऑर्डर करते हो, ज्यादा बड़ा लॉट्स पे ऑर्डर करते हो, तो आपका ट्रांजैक्शन कॉस्ट कम होता है लेकिन कैरिंग कॉस्ट बढ़ता है. तो एक पॉइंट आएगा जहां पे वो इंटरसेक्ट करता है. द पॉइंट एट वेयर इट इंटरसेक्ट्स, दैट इज द पॉइंट which reflects your optimal cash size as per the Baumol model, which is meant to be deployed for cash cost optimization. Okay, thank you.